Alright, so we're going to do this in videos of 10 each just so it's easier to go ahead and look at what's going on. So in problem number 1 we got x plus 3 divided by x squared minus 9, and the limit as x goes to negative 3. So when I plug negative 3 into the numerator I get 0, into the denominator I get 0, so we need to do something else. And this one is going to be factoring. So the top part cannot be factored. The bottom part becomes x plus 3 times x minus 3, and the x plus 3's can cancel out, so we have 1 over x minus 3. So now I'm going to plug in negative 3 after I simplify it, and so we got negative 6 on the bottom, so this becomes negative 1/6. For problem number 2, first I'll do the problem that's written, and then I'll do the problem that was supposed to be written. If we have the limit as x approaches 0, when I plug it into the top, we'll wind up with negative 20 over 0, which means that the limit does not exist. However, I believe that they wanted the problem to look something like the square root of x plus 25 minus 5 over x, which means we have 0 over 0. When we're doing the square root, I'm going to multiply the top and bottom by the conjugate, which in this case is x squared, x plus 25 plus 5, and the same thing on the bottom. So on the top I have x plus 25 minus 25, and I'm not even going to multiply the bottom out. So those disappear. And then once the 25s are gone, the x's can disappear, and I'm left with 1 over the square root of x plus 25 plus 5. And so when I plug the number 0 in right there, it turns out to be 1/10. Alright, for this problem, it's always a good idea to plug in your numbers first, because this one's not going to be 0 over 0. It's going to turn out to be negative 5 on the top over 11, and just by direct substitution we have ourselves an answer. Once again, for this one we're going to have direct substitution, which means we're going to do the cosine of 2 times 5 pi over 6, which means we have the cosine of 5 pi over 3, which is in the fourth quadrant, so the answer is going to be positive. And knowing my unit circle, anything with pi over 3 as a reference angle turns out to be 1/2. Alright, so for this next problem we need to find the discontinuities, and in order to do that I'm going to factor the top. Two numbers that multiply up to be 2 and add up to negative 3 are negative 1 and negative 2. To factor the bottom we got x plus 2, x minus 2. So x equals 2 and x equals negative 2 will be the discontinuities. At x equals 2, since they cancel out, that is one that we call a removable, and x equals negative 2 would be non-removable. Once again, this is the whole, and this one is the asymptote. Alright, this one, number 6, has another mistake on the page. It should have said limit as x approaches 2 from the left of f of x. So we need to know which one is going from the left, and less than is what comes in from the left, so all I have to do is plug in my number to that one, and we get an answer of 9. Okay, for this problem we're trying to find the asymptotes, so we need to factor the top and factor the bottom. And since we're looking for the asymptotes, we don't worry about the ones that cancel out. So we're left with x minus 5 equals 0. So x equals 5. Alright, for this next problem, I need to figure out what's happening on the top. So we got x minus 2 times x plus 1 divided by 2 times x minus 2. And we're trying to find the limit. So those two cancel. So I plug in 2. 2 plus 1 over 2 is equal to 3 halves. And over here I have 2. Since these two things do not match, that means that there is a hole at x equals 2. And if it's a hole, then it is a discontinuity. Okay, for this one, we're looking for where it's continuous. It's continuous everywhere where x minus 3 is not equal to 0. It doesn't matter about the limits or what kind. It just know that at x not equal to 3 is where this would be continuous. Last one for this first 10 problems, we're going to plug in, that's a negative 3, so I'm going to do 2 times negative 3 squared plus 8 times negative 3 minus 6, and we should come up with an answer easily enough, and that answer is negative 12.